Good afternoon. Can everybody hear me okay? All right, let's get pumped up. Everybody got the food from the food trucks, all settled down. I had a little bit of everything, tacos, Portuguese food, everything. It was all great. My name is Dennis Hills. I'm a mobile developer advocate from the Seattle, Washington, the United States. Been here for a few days, just enjoying Portugal for the first time. So thank you for having me. I'm D. Menace at Twitter, and I'm responsible for the mobile web team at Amazon Web Services, there's several of us responsible for it. But we're, a lot of times we've been talking about interacting with mobile and web, sometimes called modern apps these days. Modern apps, basically web apps using the latest technology, mobile technology, or IoT, just sort of encompassing all those areas called modern app development. And that's kind of what our team is responsible for. But today's talk is about just kind of a new approach, a new philosophy on back-end APIs using GraphQL. Then I'll talk about another service that is hosting GraphQL as a service, so it allows you to deploy secure, scalable mobile web apps in the cloud. And third thing I want to talk about is the tools to actually build it, because you need the tools, and that's what we're all about. I'm from the SDK team, so if we need questions afterwards, mobile SDK, CLI tools, besides the AWS Unified CLI, we provide tools for mobile developers, focusing mostly on front-end developers. So startups that don't have a lot of back-end experience, and you're wearing many hats, we're the place to go, because we take a lot of those big web services and categorize them, allowing you to add auth, allowing you to add a storage, database, whatever it might be. And GraphQL and App Sync are just some of the many services to build a great backend. Starting up as a service, building a great backend API, you can build mobile web apps. You can even sell the API to other mobile web app developers and make money off of that, off of the same API. So really important to build that secure, scalable API in the cloud. So, new philosophy for backend APIs. So we have the data challenge. Requirements are vary across devices. They become harder when multiple users share. Probably various ones of these, all of them or the above. Users want instant access to data. They want to see the information live. Users want to continue using their apps even with low or no connectivity. Comes up a lot where you use an app and all of a sudden there's no connectivity. Things just don't work in some apps. You want to make sure that your users can have apps that use in both connectivity and not connected. And then build scalable, data-driven apps without learning distributed systems. That's a big deal. That's why you see the popularity of the container services, the serverless movement, allowing you as a developer worry about the code and then just deploy it on the serverless environment. And it's great because you just worry about the code. All the rest is done for you. Just pay as you go. So traditional data fetching. Let's have REST endpoints. Everybody kind of familiar with hopefully a REST endpoint, where you have these endpoints called posts. This is a regular blog application. So we have posts, we have post info to get more information about the post, get title, post by author, post name start. This is your typical endpoints that you would query from a device or website to get information about a blog. And then it would pull different data sources in there and then pull that information in. So it accesses lots of information and a lot of back and forth to get that. So trivial to set up and standard HTTP calls. Okay, everything's great. So what's the problem? We run into relationship problems. Anybody's had that relationship problems where you post related to comments, comments related to the posters, lists with reduced information, query support's not there, ordering and pagination. Everybody has to do that on the client. That's a big problem. And then notifications are not set up for that. So you have to build all that in for a typical REST endpoint, web app, or mobile application. So that's the problem. So is there a better way? There's GraphQL. And now this is just another alternative, just another shift of thinking about APIs. And a lot of you are startups, so you have this green area to play with. You have a fresh start. So you can kind of approach it differently than maybe you're coming across an enterprise system. So GraphQL was created in 2012 by Facebook, then open source in 2015. And then the idea is just kind of taken off, and now we have Intuit, we have Airbnb, a lot of other services are using it at scale and secure. So it's not a solution for everything, but it's a viable option for big enterprise as well as startups. So what is GraphQL? GraphQL is a query language. That's the terminology they use. Query language for an API and a runtime for fulfilling queries with existing data. It describes what's possible with a type system, and then uniform API across data stores and APIs. And I'll go into a little bit what that looks like. Hopefully it'll make a lot of sense. So network optimized requests and responses, because remember we go back to that REST where we had to make all these requests back and forth, get the ID, get the posters, get the comments back and forth. Typically you'd make in 3 or 4 calls just to display the information you want about that one blog. Powerful development tools, and then integrated documentation and introspection is available through GraphQL. Again, open source, community driven, and another alternative to like a RESTful endpoint. So here's how it works. We talked about the REST API. We make a post, we get some IDs back from the post, then we go back and get comments for that post ID, and then we have to go get more information about the authors of those comments and posts. And so we're going back and forth to the server to make these calls. Versus a GraphQL API, you have one endpoint, and you make the call, and you get all the information in there at once. So the idea here is, we'll talk about a little more details, is requesting exactly what you want and getting back what you want. So instead of getting, sometimes you can make these 3 requests, or you can request one call, a REST API. But imagine if there's thousands of blog posts, and you're calling those back. Typically, it'd be this big, long JSON that you would have to parse through each time. And that's time consuming, and the client doesn't have time for that. It can't do the resources. So you want to be able to make single calls, but then you're making all these additional calls just to get the information you want. Whereas GraphQL will come back and give you the information you want. And I'll show you what that looks like. Say, I want the title for this, I want this blog ID, and I want these comments. So here's a typical environment for an event-based app. So we identify the query, or this is the setup for queries, mutations, and subscriptions. These are the 3 parts, the biggest parts of GraphQL. Queries, like a get event ID, and then return back an ID and a name. A mutation, just like a RESTful post. You create an event, dinner, and then I want to return the ID. And then a subscription, which is retrieving the data in real time. On create comment, I want to be able to return the ID every time somebody creates a comment for that event ID. So how to use it? So you define a schema. So we have a query with a list of events of all these events, and then we have an event static type, which is an ID, name, when and where that event takes place. Very simple. So then we go into invoke operation. So query list events, and I want to return, this is from the client, I want to return just the ID and name from that event. So it goes through, and then I get exactly what you asked for. ID, name, and then list through the information back in there. Instead of before, you may say list events, it would give you 10,000 IDs, and then it would give you ID, name, when, and where, and then you'd have to parse through that. Imagine if this was thousands and thousands of events coming from a mobile device, it's not very efficient. So imagine if I just want to add when, you add when, and that information comes back. So this is the difference where you're used to either calling everything all at once or calling each one like multiple times. And either way is not efficient, but this way you can get exactly what you want. Imagine you just have the one view, and all I need to do the first time is just display the ID and the name. I don't need anything else for now. And the next screen could do the information or pull out more details like the when and where. Or you could do a background fetch in there. Versus where we're using the REST, we're constantly going back and forth, and that's reducing the network. So GraphQL sounds legit. You need a server to run it. That's where we come in. Focus on apps, not infrastructure. So there's the same approach where GraphQL is great, but you don't want to host that server and manage all the overhead and everything else. So that's where we created AWS App Sync. App Sync hosts the GraphQL service. Remember, the service is all it is query language, and then handles all that information for you to connect multiple data sources, and I'll talk about what that looks like. So manage serverless GraphQL, just like Lambda or API Gateway, a lot of those service pieces where you just manage the endpoint and you make the connections. Connects to data sources in your account or outside of AWS account. Add data sync, real-time, and offline capabilities of any data source or API. This is really the power of it right there, is the real-time data sync. So a lot of apps these days, you want to be able to have them usable when they're offline, and the client doesn't even notice the difference. They're posting stuff, they're sending them, and then they're offline. And then as it comes back online, it just syncs with the server, and everything's seamless. So you don't see any difference. You'll see that a lot of in ads and advertising, they'll cache those ads so that you could play the games while you're offline on the airplane or the train. And then when you sync back with the service, it'll go back and send that information in. And these clients are built in for that. And then for the real-time data, we just add subscriptions to certain events. So triggers, like I want to say, I want to view on my app, I want to subscribe to any changes to this blog post ID, and then notify me in real time if I have the app open, notify me in real time if anything changes on there. So GraphQL can be used as a facade for any AWS service. So if you used API Gateway and Lambda before, it's a really common endpoint API, which is great. You could resell it, use it for your mobile or web app. This is just a facade that allows you to create this one endpoint to go to multiple data sources. Conflict detection and resolution. This is the piece where we talked about offline and online sync when those users come back online after being offline for some time and there's other changes. Automatic conflict resolution on the server side. And then we have security first with AWS. Enterprise security features like IAM, Cognito, and OIDC and API keys. If anybody's not familiar with some of these services, these are the security pieces that you can apply and allow your users, which is your mobile or web app users, to access information in your account securely. So you're protecting your information and then also theirs. So a good example, if you have a photo sharing app, you can create an S3 bucket and store objects in that S3 bucket, and then each user that signs up, they have their own repository in that S3 bucket that belongs to you, but you're reselling it to them, and they have a certain quota within that S3 bucket. So they have permissions there, and only they can actually read and write to that information. Or you can create a public folder, and they can read or write to that, and everybody else in the app can see it. So having the security first information is there. So building data-driven apps. Robust, scalable storage capable of handling millions of events a day. Geospatial search. So not only can we store data in other databases, we can actually utilize some of the services like Elasticsearch to actually save the data and automatically query that Elasticsearch service. So we get really super low sub-millisecond response. And the real-time updates we'll talk about exactly what that means. And then mobile and web app clients are ubiquitous throughout JavaScript and native Android and iOS. So some of the benefits. Clients receive the data they ask for, nothing more, nothing less. So hopefully that's clear. That's kind of the key to GraphQL as well. That's just, you ask for just the ID or the name, or you just want the time and location of the event, and you get that information, versus you would typically do a call, get all the IDs back, and then start querying information there. So get many resources from many data sources with a single request. I'll show you visually what that means so you have a better idea of those multiple data sources. And then self-documenting APIs with introspection, which allows you as a developer not have to write as much documentation, which is helpful for everybody. Again, native Android and iOS, WebJS using Apollo GraphQL client, and data persistent across application restarts. So this is part of the client. Not only are we providing this GraphQL open standard, but we're providing these client applications and SDKs and tools for you to go and say, okay, I want to create this offline first. I want to be able to have it persist data across on mobile and web. And then I want to write through mutations with optimistic UI. And optimistic UI, you know what that means? Just it means like I'm offline, and it acts like it's saving to the back end for the user. The user doesn't know the difference. That's really optimistic UI is. So you're just saving data, saves to the back end. If you're offline, it kind of just saves it in the local cache or local SQLite or whatever it is. And as web or mobile developers, you probably have done this before, but it's not easy to do. And you're always constantly working on the client. This is something that we provide for you, or you can utilize that available to you, that optimistic UI piece where you could say, I want it to always go to a network, I want it to always go to the device first, and then when it's available, right to the network. Whatever you want to do, it's your choice, and you have that opportunity. So that way you're creating this offline first, optimistic UI. So hopefully this is better. I like visual. So you create, import, upload a GraphQL schema, and then you connect it into multiple data sources. So we talked about offline, we talked about the sync things, but this is where it gets really cool. When we talked about like any of the events app, we can make one single API call and do a select for any of those posts or events. And then behind the scenes, it could go to Lambda, it could go to DynamoDB, it could go to your own HTTP endpoint in your own server, it could go anywhere. So the idea is one call, making it from one end to the other, and then in between that, you could have one or more services combined and return that same information. So we talked about those queries where we get an ID back, comment, and authors. It could be 3 different disparate databases or data locations, and then query that together, and then bring it back as just ID and author if you wanted to. So App Sync updates the data in real time and then manages data when offline. So that's part of the client and the server, so everything's kind of mixed in together. It's kind of a cool graphic, but I don't know if it paints a picture as much there, but the idea is everything's done for you both on the server side and the client side for optimistic UI. So here's the data flow. So remember we talked about the data sources in the middle? So as mobile or web, I make the request, and then that request is a template. That template is going in there and making the request into data sources. Anybody create like a SQL view or a stored procedure? Think of it something like that, where it's all kind of done behind the scenes, where I need to do a select statement, joins, and all that information. That's kind of what the request template is doing, putting that information in there, and then going in and pulling that different data sources. So the user doesn't know it's the same API call. I just need the ID of this blog post. That's it. And it goes in there, and it maybe pulls from 2 different sources, does some other things, and then just comes back. And then the response template, again, you could go and do something different, tweak it, and then it responds back to the user. So it could actually do some real-time queries, a lot of different things it could do, and then responds in JSON back to the user, whatever they requested. So again, they're not asking for this big blob of JSON that they have to query and parse inside the app anymore. It's all done for you. So there's a little bit of extra work ahead of time where the request template and response template, VTLs they're called, and you create these templates and you can modify them any way you want. So a lot of things like you could check the security, you could do all these sorts of things that are able to do and then respond back to the user. A lot of server-side stuff. So 1, 2, 3, 4, those are the steps, and then back to the user. And these templates, this is all the stuff that's going on with the hosted GraphQL service, which is App Sync. So here's another picture of it. App Sync integration, so websites, services, mobile apps connect into your App Sync, can log also to CloudWatch if anybody's familiar, real-time logging of the information. And then behind the scenes, it could go to Lambda functions, HTTP. Amazon Elasticsearch is that really nice low latency search results based on the data that you're providing. And then from there, you could actually go anywhere. If anybody's used Lambda functions, they're just beautiful. And you could have it go to EC2, RDS, and then actually publicly HTTPS or accessible endpoints. You can even make an API gateway call if you wanted to. So you can kind of play with it a little bit. Just decide exactly how you want to play with it and then implement it. You can put a facade in front of API gateway or Lambda, or just build it something like this and have multiple data sources. And this seems maybe more a little overkill, but as your application grows, you may need additional stuff like DynamoDB or the Lambda functions just to do certain webhooks and information like that. Okay, so here's a mix and match of data sources of GraphQL types. So we got the information here where I'm searching posts and listing posts, and then you can see where the queries and mutations come in, and the type of information just comes back, and that's it. So really quick and easy, information back, and you can remember, you can get back ID only, or you can ask for just content, just description, or all of the above. All those are options to you, versus what would happen before. You'd have to query all of them, and then go out and filter each one of those out. Anybody sold yet on GraphQL? Nope? Okay, he is. Good. Okay, let's talk about real-time and offline, because this is a big deal. This is the piece where we're talking about like webhooks. Talks about, whoa, that's a little busy. Let's talk about before App Sync. So we got a browser, and anybody who's doing real-time, webhooks or MQTT, it's just a way for your users to get their real-time information. Anything from like real-time sports, stock tracker, any blog posts, whatever, anything real-time that you want, and you're in the app, automatically sends in there that's automatically synced into your device. So typically we'd have these HTTP endpoints, which is search, taps, in search, web servers, WebSockets, pub sub servers, back into subscription, and then pull around. You imagine how messy that can get. And that's kind of a typical WebSocket connection for a web app these days. So this is another powerful piece of GraphQL. So simply create this GraphQL endpoint, make the call, subscribe to whatever you want, which is an update to DynamoDB, maybe a new post, maybe a new comment, maybe a new author's been added, or you just simply do an Elasticsearch query, or you send it to a third-party service that could also trigger information. So it goes to a third party like Salesforce or something that might be able to pull that, and you would trigger that information. And that user has the app open, and that's real time. So it creates the WebSocket connection to the client for you. And again, so we have this real time, we have offline reconnects, and it's all back in stage for you. So again, you're just worried about the backend API and make the one single call, and all the client and service is all doing that work for you. So GraphQL subscriptions, just basically WebSockets, MQTT. If anybody's ever done WebSockets, you know the difference between the pull. You're constantly pulling a site every 5 seconds. Websites do it. They constantly pull. It's inefficient. So WebSockets is created for MQTT, which allows you to create this website or mobile app that's native, and you can actually get this information. It creates a socket connection, direct connection with the API service. So you'll see this a lot in third-party services where you're doing a chat. You always want to be able to keep a WebSocket open instead of keep polling the server, because it's just too much latency, too many API calls. So developers will create WebSockets so that it creates this connection, a tunnel, so that things just stream in really quick as it goes through. So you have client-managed WebSocket connection. You do whatever you want with that thing. So here's what it looks like. You get the token. You send the request. Operations involved for the App Sync client. Send the login user's token as part of the request. It does a conditional check, and then it runs an operation. So this is one of those where you could have a security operation going on, and then get information like ID, author, and data. So again, secure by default, so that you could only allow your users to access their information or public information or a combination of both. So another great piece. So we talked about offline, we talked about real-time sync. This is rich data. Anybody use Amazon S3 for storage? Super inexpensive, low latency, great service for storing objects, video, text, anything you want. So we have the service where if you upload to S3, it also creates that metadata in a database. So it's great. Just say, I want to put this S3 object in there. I have a bucket and key defined in a region. And then every time I upload this object, it automatically puts this information in, like the name profile, inside of DynamoDB for me, or another database if you want. So you see SQS does this a little bit for you if you use a certain type of client. But this is done for you where you can just make that one single API call with the information in that object, and then automatically save to the database for you. So this is very powerful if you just want to upload images, 1 meg, 2 megs, 10 megs, uploads to S3, the object, and then puts that information in the metadata, so you don't have to have these additional services. You don't have to make another call to let you know whenever that object's been uploaded, and automatically syncs with the SDK. So here's where it might work. Profile spec, S3 object, and then you have the bucket key defined from the server side with the schema. And then again, goes into DynamoDB and then S3. So everything's all kind of done before you. You can also do a Lambda function, S3 trigger, so you'd upload an object to S3. S3 could trigger Lambda. Lambda would go to DynamoDB and put that profile information in there for you. That's the other alternative. And that's fine too. But imagine if you could just have it done automatically and just all in sync. So that's kind of the advantages of having the GraphQL and the App Sync client with you, so you could do these objects things. And a lot of times our services will provide a grouping of different services of categories for this reason, because we've heard from customers say, okay, I want to be able to provide this service. I don't want to go to S3 directly or create additional services to write DynamoDB. I just need to get this object into the cloud, and you can do it this way. So here's where it might work. This is the logs. You'll see the S3 key and the location information, the bucket, and the name, App Sync, John Doe, and then private. And that's the information that will give you for sending that object, and that's pretty much it. So you'll be able to log that information about the bucket, what object it is, where it's stored, and then some metadata if you want to ever pull that. Again, we can pull up Elasticsearch and query on that data immediately, have a subscription to it if we wanted to. So imagine that everything's uploaded to S3, that we have subscription to it, everything's kind of real time, And then if it's offline, it'll go ahead and throw that object on the S3 and update the database when it comes online. So everything's really seamless for you. So we'll go offline capability real quick. So we talked about the offline optimistic UI, right? This is important for mobile developers, especially when the connectivity is not real efficient. I mean, it's been great here so far, I think, but when I'm traveling in subway or on the plane, I just don't have that connection. Or even in the elevator for like 10 seconds or 15 seconds, and you're uploading an object or sending something to a friend. You can actually local store with the web, async storage with React Native, SQL Store native platforms. So there's various ways that you could tweak it as the mobile or web developer. You could say, I want to save it locally, or I want to go only to the web. Depends on the application. Sometimes you just want to avoid offline out completely and say this needs to be sent to the network, and if the network's not available, then disregard it. You know, for like those real-time stats for Wall Street. So the other ones just are available to you, Wi-Fi only or Wi-Fi cellular. So you have an option of like, I want to sync this only when it's Wi-Fi or only when it's Wi-Fi or cellular or both, whatever you want. You have that control. So that's pretty much GraphQL, App Sync, and then the client's available for optimistic UI, real-time, and then a couple of the S3 objects were the three biggest pieces. And again, it's the managed service, which is also serverless. So it's kind of great. It's a lot of everything that our customers are asking for. So now the last piece, I want to talk about developer tools. Like, how do you build this? So that part of our team is creating tools so that you can just go and build it. We have AWS Unified CLI, we have the console, we have all these tools. But as a mobile web developer, front-end focused, we want to be able to create these tools that allow you to focus on categories, like you talked about earlier. Like, I just need to add auth. I don't need to know about API keys or IAM or security rules. I just need to do auth. And I need Facebook and log in with Amazon. Or I need another social provider, OpenID. That's it. And I need storage. Okay, S3 bucket, you got it, done. So that's the idea behind AWS Amplify CLI. Anybody use Amplify CLI or heard of it? Okay, few of you. So this is for mobile web. This is focusing more on the front-end developers instead of the DevOps. So you see a lot of AWS services focus on DevOps. This is focused on the mobile web, modern app, front-end developer who's kind of wearing that multiple hats. It allows them to create this applications we talked about with App Sync or web or mobile using just the CLI command, and then you're deploying your resources directly from your environment. So let's say I'm an iOS developer, and I want to create an application, created this great offline application. I would use the CLI to cloud enable this application and then start adding these features, categories. I'll talk about that. So you could do analytics, API, auth, functions, which are just Lambda functions. You can host a web service on S3 or CloudFront, interactions, which is chatbots, notifications, which is that real-time notification piece, and push notifications, and then storage is the S3. So instead of like understanding what S3 is or understanding push notifications, we just query you and say, okay, what information do you want? Are you on iOS app? Great. Do you want to send push notifications? Or do you want to set up auth? And it'll say, do you want username and password? Do you want to allow users to log in with Facebook? Sure. And then it'll set up all that information for you. And then based on the platform you're on, let's say for iOS, it would ask me for information about my iOS app. And then I would run CocoaPods and install the SDK, which is the AWS Mobile SDK for that, and then apply it. And then automatically have a built-in UI that I could allow users to sign up with Facebook. And then those users are secure and have a secure ID that will allow them to access my AWS resources. So like go back to that scene where they're posting blogs or they have a notes app. If they log into Facebook, they have a unique ID that's good for them, multiple devices if they want. As long as they've logged into Facebook or any OpenID provider, they have secure access to their resources within my account. And so that's great because then they're the only ones that can access it. And if they log out or if anybody picks up the phone, nobody can access those resources except for them. So here's an example. What happens? So you set up Amplify init. It asks you kind of your default editor, some JavaScript. If you're iOS, JavaScript tries to pick out what your app is. In this case, it's a React. And then information like what's the source folder, what's the build directory path, and then what are scripts to run this. and then it creates a standard CloudFormation template locally, and then when you're ready to go, you simply just do a mplifi push, and all it takes is that CloudFormation template and sends it up to the cloud as a stack to build your resources. Now, if anybody hasn't used CloudFormation, which probably most of you haven't, it's a really nice automated tool which goes back to the DevOps. They love this because they could just automate things and do a blue-green environment. They could do A/B testing. But it's great because it defines all the AWS services in one like JSON or YAML file. Then they deploy it to the cloud, to CloudFormation, and then CloudFormation builds all these services for you that are tied in. Because as you know, you can't just create a bucket. You got to create the access code to the bucket. You got to create the roles for those users to assume and be able to securely access your resources. So it's a little bit more than setting up a bucket and running with it. So you got app details, then you have the credentials, which is auth and unauth role. Really simple, but pretty straightforward with this because it allows you to just say, okay, I'm going to set it up for my users. I'm going to allow unauth or auth. Unauth means that you're not asking the users to log in. You're just going to use the device as authentication mechanism. And with this service, you're saying, okay, I want to allow the user's device to be able to authenticate. So they could read, write, whatever they want. But if they delete that app or they log out or they delete your app on the device, it's gone and they become a new user. So as long as they keep that app and that same device, then they can go ahead and create and add stuff to that device. So it's really nice allowing your users to make that decision whether they're going to be logged in or not. Because you don't want to always require users to log in. It's a barrier of entry for you. And so if you could allow them to be unauthenticated, which means it gives them still a secure token to access your resources, it just doesn't carry over to other devices because it doesn't know who they are. That's the only disadvantage for those users. So they would be able to just only share with there's one device. Okay, so GraphQL or REST. The bottom line, it depends on the use case. So I'm not here to sell GraphQL because I love both REST and GraphQL. It just depends on the use case. But since a lot of us are startups, this is a great opportunity to go in there, start from the beginning, and take advantage of the WebSockets built in, the offline, the optimistic UI, and then utilizing the tools like mplifi CLI to give you all those features, the feature category based, like with auth, storage, database, whatever it might be. So good API design, that's really what it comes down to. Come away with this. Set up, if you're starting up and you have a mobile web app, API design, not just because I work for AWS, but a really good API design that's secure and scalable is the most important thing. Start collecting analytics, build a great backend API, and then everything else just comes from it. And again, remember, we could be a startup, we could have a great API, and we have this great mobile app that's doing okay, maybe it's ad-based, maybe it's making some revenue. But if it's a great API, we can actually sell it using some of these tools, rate limit and throttle other developers. So let's say I'm making a weather app, and I have a great API, right? I could actually have an app, and I'm making pretty good money on the app, but I have this great data. But I could actually resell that to other mobile developers who want to create a 5-day, 10-day forecast or tornado warning app forecast. I have the data in my API, and then they create all these apps based on that API. We're all connecting to the same API, but I'm just making money from all these different areas. So I could give them an API key, $10 a month, $15 a month, depending on how much data they're going to pull, and then you're done. So it really starts with that API, and that's secure and scalable by default. With all these services, when we enable them, they're not just like, okay, this is good for a couple weeks until we get big. These are literally set up so that I could be millions of users overnight. That's what's so great about this. A little bit extra work, set it up, you can be millions of users overnight so that you're not on Shark Tank the next day and all of a sudden like, oh, whoops. And they're saying you need to scale. And they're going to call us and say, okay, this customer is going to be live in a week. You don't have to worry about that. And again, a lot of these serverless pieces that you see, the services are just sitting there and you're paying nothing for 2 months. You're in development, you're paying nothing. And then all of a sudden things start taking off. This is great. And the investor's not paying anything for your service until you start getting to a certain level. Then you start paying for use, which is a good thing to happen, right? Then you figure out if you're going to monetize a certain way. You got other investors. But the API starts with a great API. and then everything else comes to play in the app. So don't ever worry about like the frameworks, the mobile, website, the good API design, and then figure out which way you want to go with an optimistic UI, some kind of syncing capability, and that real-time notification. So I'll leave you with this. REST and GraphQL are totally different. GraphQL isn't a magic bullet. Oh, by the way, GraphQL is not a graph database, if anybody's, probably should have clarified that earlier. It's not a graph database. Graph meaning just a generic term of storing stuff in a database like in a graph. And you can definitely use both at the same time. GraphQL is dope if used for the right thing. So again, I'm not trying to sell it, but it is a great way to start out. Think about all those features that are added on top of it. And it's community driven. So if anybody's into the open source and not trying to use the proprietary information or APIs, you can go there, and the Amazon or the AWS Amplify CLI is open source and community driven. Got great support. The GraphQL is an open standard and fully supported. So you can go and ask questions, you can go out, create issues, do whatever you want. So Amplify is available through aws-amplify.github.io to get started. And then App Sync is just aws.amazon/AppSync. And again, this is the hosted GraphQL service with so much more, right? All those pieces wrapped into the API and all that other cool stuff. So go build with AWS App Sync and GraphQL. That's it. Thank you.